We're on a journey from field to fork.
By 2050, there are expected to be 10 billion people on the planet. How to feed everyone is a profound question for the whole world and is set to transform farming in the decades ahead.
You feel like you are part of the change that could transform the way people eat.
From preserving water, the lifeblood that feeds the crops.
We've increased our water use efficiency by over 33% in the 20 years.
To regenerating the very soil they grow in.
This is a liquid fermenter that allows us to scale just a little bit of microbes into a lot of microbes.
From sustainable and safe food.
Welcome to the largest vertical farm in the world.
To protecting the environment and reducing waste.
It's an amazing feeling to see that you can contribute to something that will change the world.
To explore how innovation and modern agriculture are leading the way.
It's fundamentally a game changer for farmers around the world.
To reform our land and diet, and connecting farmer to consumer. In this episode, we're looking at soil and how protecting the health of this vital substance is key to providing enough food in the future.
Welcome to Follow the Food. Soil is the bedrock of our food chain. Whether it's used to grow food for humans or grass for our livestock to graze on, it affects everything we eat. But climate change, urbanization, and intensive farming have massively depleted our reserves. It's estimated that if the current rate of degradation continues, all of the world's topsoil could be gone in 60 years. 95% of our food is directly or indirectly produced on our soils. But each year, mankind is destroying 24 billion tons of fertile land through mismanagement. It's the equivalent of losing 30 soccer pitches every minute. If nothing changes, this figure is only set to rise. With an estimated food consumption increase of around 40% by 2050, scientists and technologists are beginning to understand how climate change, land degradation, urban sprawl, deforestation, desertification, irrigation, and unequal land distribution are all contributing to a serious decline in available fertile land from which to farm. Whether it's through intensification or extensification, or an element of both, the global race is on to discover and innovate new, more efficient, and sustainable farming practices. Around the world, soil conservation is now as important an issue as protecting our climate and conserving our water. Today, exciting billion-dollar industries are realizing the potential value for developing ways to save our soil. We've long known that microbes in our bodies play a critical role in keeping us healthy. But what we're learning is that they do the same for plants and crops. Therefore, if we need our farmland to produce higher yields in a sustainable way, we need to figure out a way to harness those beneficial microbes.
And that's exactly what one Boston-based startup is doing. Indigo Agriculture was co-founded by Jeffrey von Maltzen less than 5 years ago. It's now valued at over $1 billion, a sign that there's money in microbes.
Soil is super important for the health of crops, but it's really over the past 10 years that it's become clear that there's an additional community of microbes that's really important to the health of plants.
Vital to soil fertility, microbiomes play an important role in the health of plants by fixing nitrogen from the air, preserving water, or even protecting from fungal disease. Soil that is deficient in microbes is no good to any farmer.
So what Indigo's doing is putting thin films of microbes on the surface of seeds, where those microbes' role in nature is to protect the plant from pathogens and stresses. So heat stress, drought stress, cold stress, insects, fungal pathogens, bacterial pathogens. We go out and look for, under conditions of stress, the plants that are the most extraordinary survivors under that stress. They take samples very carefully from those special plants. We bring them back to our labs. We've built a microbe collection of 50,000 plus microbes here. We then test those in corn, soy, wheat, cotton, and rice. And the microbes have shown 5 to 10% improvements in yield.
Incredible.
Finding beneficial soil microbes is the work of Barry Goldman. He's got a great title, Head of Discovery. I want to find out how they discover these bugs and turn them into seed treatments.
This is a cutting from a plant that was a healthy plant in a field that was not so healthy. And the idea is to isolate the microbes. Once we've isolated all these beauties, we try and sequence them.
So that's what we're going to see next?
That's what we're going to see next.
Let's go see. The input into this machine is the microbe.
Right, exactly.
What comes out?
What comes out is a little piece of DNA sequence. And from that sequence, we can understand what is the microbe.
And you can start to understand maybe this DNA sequence works well for drought.
Yeah, so we can make some of those conjectures and predictions based on that little bit of DNA.
Once identified, good microbes are made into test coatings to see if they'll make a real difference to plant growth. Those experimental seedlings are then analyzed, and the largest and strongest ones selected for further breeding in what's known as the growth chamber.
This is the place where you can put the stress on the plant that they might experience in the environment outside.
Yes, absolutely. And usually we grow them for about 3 weeks.
How many successes do you expect to find?
Yeah, about somewhere between 5 and 10%.
If you get to the field and you see increased yields, then you have a microbe. Then you've got a winner.
Then we have a product. In order to put the microbes out into the field, we need a lot of them. This is a liquid fermenter that allows us to scale just a little bit of microbes into a lot of microbes.
Once the process is complete, crop seeds are coated with these super soil-loving microbes, enabling them to eventually grow into more robust, superior plants.
So these are the treated seeds. They have microbes on them. They're ready to go out in the field.
Done.
With the ability to provide individual plants with a package of beneficial ingredients, Indigo hopes in the future to tailor microbes to a farmer's individual needs wherever on the planet they farm.
We are now commercially active in the United States, in Brazil, in Argentina, in Australia, and in India.
And how expensive is it?
The seed is more expensive, and our product we price according to the benefit that the product has.
So if their yield is higher on the other end, it makes up for the increased price of the seed?
That's absolutely right. Over time, you can imagine tens, hundreds, thousands of microbes becoming a part of the ability to impart every seed that's planted in the world with an advantaged microbiome for its specific location, for the specific stresses that it's going to be under.
To further understand the impact soil has on our ability to grow food, I've come to Ohio State University to meet someone who believes soil health is intrinsically linked to our own health. Professor Ratan Lal is an award-winning soil scientist whose acclaimed research has focused on how we feed a growing planet and combat climate change.
Do you believe that people understand the importance of soil?
Not as many as I would like to. If people understood that this was a precious and very fragile resource, they would not take it for granted as they do. There is no law that says soil resources must be protected and not polluted.
Can you paint a picture for me of healthy soil versus unhealthy soil?
Healthy soil will be dark, rich, fluffy, granular. You pick up a degraded soil, it is very dense. The organic matter is not there, so instead of dark brown, it is reddish yellow or gray color. Micronutrients, 17 of them, come from soil. And if a soil is deficit, then it produce, whether it's plant or animal, is deficit in that. And that will be reflected in the health of the people who live in it.
What can we do to improve our soil?
Well, soil is like a bank account. You can never take out of a bank more than what you put into it. Soil is the same way.
Somebody in your office has referred to soil as the next gold rush.
I would say it is the final frontiers that we can learn how to protect, how to use, how to restore judiciously and properly. I think that's the approach we should have.
Looking for ways to protect what fertile soil we have left will become increasingly important in the future. After the break, I discover how Ethiopian farmers are helping to bring farmland back to life. How a research facility once focused on space is now researching soil. And how perennials are doing the job of annuals.
This time of the year, Kearns Field looks pretty dead, but below ground, we know there's a big party going on.
Soil is a finite resource, and if we're going to protect it for future generations, we have to have a better understanding of how it's formed. That's what they're trying to do here at Biosphere 2. I've come to the Arizona desert in the USA to a unique research facility that is home to the largest earth science experiment in the world and could unlock the secrets of soil, Biosphere 2. Built in the early 1990s, this amazing building was originally constructed as a test facility to help understand whether humans could one day maintain life in outer space. Today, though, research has returned to Earth and now focuses on a bigger and rather more immediate problem. Owned by the University of Arizona, researchers at Biosphere 2 are unlocking the secrets of science to understand how soil is made in order to protect this valuable resource. Professor Joaquin Ruiz is the director. What do you hope to learn from your soil project?
The biggest question that we have is how quickly you can make soil. So we're creating soil. And the most important, perhaps, for soil scientists in our experiment is the evolution of the microbiome in the soil.
Can you explain what is the microbiome of the soil?
It is all the microbes that exist in the soil that can influence how plants survive.
Where do you get the soil in the first place?
So we went up to a quarry in northern Arizona, which has a rock called basalt. We chose basalt because it's a rock that's going to react with the atmosphere quickly and start creating soil.
Understanding the evolution of soil and its relationship with the environment around it is the work of scientist Dr. Laura Meredith. Her research is based at the Landscape Evolution Observatory, an area of Biosphere 2 consisting of 3 artificial hill slopes, each roughly the size of a basketball court, filled with crushed basalt rock and weighing nearly 900 metric tons. What are you trying to find out here?
The big question that we're trying to answer when it comes to soils is how do soils evolve from rock?
How does the crushed basalt turn into fertile soil that you can eventually grow stuff on?
That's the question. So we know that mineral itself, without biology, will weather. But we also know that life is really important and can come and attach, and it creates acids or bases that can facilitate that weathering process.
How? When you haven't introduced anything else into it.
So microorganisms can deposit onto the hill slopes, and when it rains, they can be transported into the soils and they can grow.
Can we go take a closer look?
Of course, follow me.
The sloped hills help explain how soil is created by exposing them to real-life conditions. Wow.
Yeah.
You can get a much better view of it from here. How long ago did you put the soil here?
It's been here for about 4 years.
When I look down on it now, I can see it mimics the earth a lot more than I thought it did.
Yeah, it looks like a watershed.
And when will you put plants in it?
We're hoping to add plants within the next year or so, and after we've finished characterizing the microbiology.
The delicate environment is controlled and monitored by a range of sensors and samplers above and within each hill slope that over time should begin to create a picture of the complex way in which soil is really formed. In 20 years from now, what are we going to look back on Leo and say, we learned this?
I think Leo really has the potential to be a long-term observatory, and future generations of scientists could monitor and really understand how soils evolve over even longer time periods.
This facility offers scientists the opportunity to research the fundamentals of how soil is formed. It is a slow process, but the data being collected here has the potential to radically further our understanding of this invaluable resource. Across the Atlantic in Africa, protecting fertile soil is also becoming the focus of forward-thinking farming. A steady population rise and the increasing problem of climate change are forcing the agricultural industry to make big changes. In Ethiopia, the continent's second largest populace, almost 85% of people are engaged in subsistence farming. But worryingly, a large number still live below the poverty line. A decline in fertile farmland here could be catastrophic. In Benasemai, uncontrolled grazing has resulted in the vast reduction of fresh pasture land for pastoralists. And one visionary cooperative is working hard to turn this around. Otto Burgai Bezaba is its champion. With the help of Farm Africa, the Rangeland Administrative Cooperative was established. This community-led initiative was set up to bring some of the land thought to have been degraded and lost back to life. Conservation efforts, such as fencing off land to help it recover from overuse and planting new, fast-growing grasses, helped restore the topsoil and turned this previously barren part of Ethiopia green once again. With the Rangeland Administrative Cooperative providing a blueprint for other regions across Africa. Whether it's resurrecting soil through the use of low-tech solutions or boosting fertility with high-tech innovations, farming is still largely an annual cycle, a process that has its own effect on soil health. Each year, around 70% of global croplands are sown, grown, and harvested within a matter of months. And each cycle, more and more pressure is placed on the soil. Heavy tilling, multiple harvests, and abundant use of agrochemicals designed to protect yields have been at the expense of long-term sustainability. Solutions, though, are at hand. At the Land Institute in Kansas, work is taking place on new crops and farming methods that are putting soil health as top priority.
Our big goal is to reset agriculture so that it functions the same way that a natural ecosystem does. Most agricultural systems in the world have a net rate of soil erosion. Every year, more soil is leaving than is being newly formed. And long term, nothing less than the fate of humanity and the fate of the planet rests on getting net soil formation to a positive number.
One way of achieving that is by planting perennial crops. Unlike annual crops, perennials don't need to be planted every year and can be harvested multiple times before dying.
We are in a greenhouse here at the Land Institute that is full of intermediate wheatgrass plants, which is a plant that produces the grain kernza. Kernza is a relative of annual wheat, and yet it grows year after year. You don't have to plant it more than once. It does not take very much convincing to a farmer to understand the value of continuous living cover over their fields indefinitely. And kernza's roots go deep, meters deep into the soil, and they're there year round. And so the quality of soil goes up under kernza, the soil structure improves, the way in which water infiltrates into the soil. All of these benefits farmers readily see and want.
Using a technique known as genomic selection, researchers use information obtained from the plant's DNA to inform them which to select for further natural crossbreeding in order to accelerate and fine-tune the plant for commercialization.
Right now, kernza is only yielding between 1/6 and 1/3 of wheat. Kernza as a crop is just beginning to be commercially viable. We have a number of growers in the US planting it in fields. It's being trialed in France, Sweden, Australia. We just need to keep at it. We are in a Kernza field that was planted about 7 or 8 years ago. This time of the year, Kernza field looks pretty dead, but below ground, we know there's a big party going on with lots of microbes. And the bodies of those microbes, the dead bodies, are what build stable soil organic matter.
Not only are these perennial Kernza plants helping to rebuild and reinvigorate the soil structure, they're also working hard to pull excess carbon from the Earth's atmosphere, locking it in the soil.
People ask us, how do you know that Kernza is locking up carbon in the soil? So this eddy covariance tower is how we know. It's an instrument that essentially measures the carbon that's going in and the carbon that's coming out of the ground. And this particular field, we know, is gaining quite a bit of carbon. I have not come across another project that addresses the scale of problems in agriculture. You feel like you are part of the change that could transform the way people eat. The potential for people to be eating Kernza 10, 20 years from now is extremely high in a wide array of products. This crop is a game changer.
Only time will tell whether this perennial grain can really equal its annual cousin, wheat. But if it can, then the way farmers produce this staple crop in the future could see a big impact on soil health around the world. Globally, soil degradation is happening at an alarming rate, and this is only set to continue as the demand for food and productive land increases. But as we begin to discover soil secrets at a microscopic level, we put ourselves in a better place to protect this invaluable resource. Time is running out to protect the fertile soil we have left. Find out about the innovative work taking place around the world to save our soil at bbc.com/followthefood.